Since the early days of rocket science, rocket engines have been used to reliably create the enormous thrust required to break Earth's gravitational bond. During launch, the Space Shuttle main engines blast out enough steam to power 1/3 of the Californian power grid. Imagine harnessing this tremendous energy.
Liftoff.
Over the past 18 years, the California-based company Clean Energy Systems has turned imagination into reality by enabling the same reliable, clean, and powerful principles to be used in everyday energy applications. This energy is produced in a process called oxy-fuel combustion, in which fuel is combusted in a pure oxygen environment. The continuous supply of oxygen requires an air separation unit, which separates air into its constituent parts at high purity. Here, the air is cooled to very low temperatures, liquefied, and physically separated in a cryogenic distillation process. Separating out the nitrogen before the combustion process avoids the formation of nitrogen oxides, or NOx, during combustion. Nitrogen oxides are difficult to eliminate air pollutants, typically tied to power production. At the heart of the CES system is CES's proprietary oxy-fuel combustor, or gas generator, a rocket engine re-engineered to run continuously. Typically, fuel comes in the form of natural gas or associated gas. However, because the CES gas generator burns fuel in a pure oxygen environment, a large variety of fuels may be combusted, including those which are normally uneconomic, such as CO2-contaminated gas or CO2-EOR, recycled gas. Inside the gas generator, high-pressure water, fuel, and oxygen are delivered through an intricate network of pathways into literally hundreds of small combustors on the face of a platelet stack, the core of CES technology. Each combustor outlet precisely mixes fuel and oxygen stoichiometrically to ensure a clean and complete combustion, leaving no waste in the drive gas. Water is injected into the combustion chamber in several stages to achieve reassociation of combustion byproducts and to quench the drive gas to the required temperature for the equipment downstream. A cooling jacket around the combustor is used for both preheating the water before being injected into the process and for cooling the equipment itself. After exiting the gas generator, the drive gas enters a conventional high-pressure, non-condensing steam turbine to generate power. To fully exploit the capabilities unlocked by CES technology, CES, in collaboration with Siemens and sponsored by the Department of Energy, redesigned the existing 43-megawatt SGT-900 for oxy-fuel combustion, making it the oxy-fuel turbine, or OFT900. Future units of the OFT900 will be known as Siemens Expander Turbines, or SXT-150. The primary advancement of the OFT900 lies in the replacement of traditional combustor cans with reheater oxycombustors that work based on the same principles as the CES gas generator. Having the drive gas enter the turbine at the required design pressure eliminates the need for the traditional compressor. Steam is injected into the OFT900 and passes along the shaft into a plenum before entering the reheaters. While maintaining the pressure of the drive gas, the reheaters boost temperatures to the ideal inlet conditions for the OFT900 expander section, where roughly 150 megawatts of power is generated. The residual energy of the drive gas is converted into power in a low-pressure steam turbine, or used for water desalinization. After the turbine or desalinization process, the remaining steam is condensed to water, which gets recycled to the gas generator. On the other side, concentrated CO2 leaves the condenser. The generated electricity feeds to the grid. After conditioning and compression, the CO2 gets dispatched to a nearby field for enhanced oil recovery. And after cooling, the generated excess water is sent off as commercial product to agriculture or industry. Throughout the process of generating power, water, and CO2, the CES system has zero emissions, making a stackless energy facility possible while providing efficient and attractive solutions for zero emissions power, enhanced oil recovery, and unlocking resource value.